So how does a loop help us here? Why do we need a loop? Because we want to repeat a certain operation. We want to add numbers up to this number, and that means that we need to perform multiple additions, so the same operation multiple times. That's where a loop can help us, and in Go, like in many other programming languages, we can create such a loop by using the for keyword. That creates a so-called for loop. Now, the for loop can take many different shapes and forms, and we'll see all those different ways of using for in this course section. But the most straightforward and standard way of using for is to use it with a helper variable that exists only for this loop, that changes after every iteration. Typically, that helper variable is a number, which then, for example, is incremented after every iteration. And we then have a condition that keeps the loop running as long as it's met. So let me show you how that works. We start by initializing that helper variable. It's a brand new variable created with the colon equals an operator, and it's created in the same line as the for keyword, and it will only be available inside of the for loop, therefore. And we use I as a variable name typically because that stands for iteration, but technically you can use any variable name you want, including longer names. But I is the convention. Then we add a semicolon. One of the rare cases where we manually add a semicolon in Go, because we add another piece of code in the same line still. And the semicolon tells Go that a new code expression starts, even though it's in the same line. This next part is the actual condition that keeps the loop running. As long as the condition is met, the loop keeps on running. And here we use a condition just as we did it in if statements. We can, for example, check that I is smaller than 5. So as long as I is smaller than 5, the code, which we'll soon write inside of the loop, will keep on executing. Of course, since I is 0, this condition will always be met. And that's why we have a third part here, also separated by a semicolon. We now define how I, this helper variable, should change after every loop iteration. For example, we could say that 1 should be added to it, or 2, or we multiply it with 2, whatever you want to do. Now here I'll simply add 1 to it. That's the most common form of changing I in a loop. And there is a shortcut for this. You can write it like that. That's the equivalent to setting I equal to I plus 1. It's simply shorter and it increments I by 1. Then we add our curly braces, and now here we can write the code that should be repeated. In this case, that should be repeated 5 times. So here we can then, for example, simply print I, and to test this, I'll also print chosen number outside of the loop so that we don't get any complaints because this variable is not being used. And with that, we have our first dummy loop in place. Now let's give this a try. We can run this program, and we are then prompted to make a choice. And here we want to choose 1 because that's the only function where we actually wrote some logic up to this point, our dummy loop logic. So I'll enter 1 and hit enter. And then we enter any number of our choice, for example, 1 again, doesn't matter. And now we see this. Now we see that this seems to work. Here we see the output from our loop. 0 to 4, 5 is not a value we see because we only keep on looping as long as I is smaller than 5. If it's equal to 5, we'll quit this loop execution. And that's why we see this output, and that's how a loop generally works now. Now there's one little change, one little adjustment I want to make, not directly related to my loop, but of course when I'm getting a new input number here, I want to give the user a little bit more information and hence actually print a little message here where I say, please enter your number. And now that's not a number for making a choice, but the number up to which we'll build a sum later. So just to add more context. And I'll also go to get user input. And here, before prompting the user for input, I also want to say, please make your choice. Like that. Now I added a little bit more information by outputting more information here. And now we are ready to work on that loop and switch from that dummy loop to a loop that actually does something useful for us.